So, hello everyone. In today's video, I'm going to discuss about laser welding and TIG welding, and also a comparison between them. So, let's start with laser welding. So, there are different types of lasers used in laser welding. Among them, I have listed some of them, like solid. You can categorize these lasers as solid state laser, gauge state laser, and liquid state laser. And among them, the most commonly used are Nd:YAG laser, which is neodymium, yttrium uh, garnet, like that, yttrium aluminum garnet, and ruby crystal. And gaseous state laser is CO2 laser, and liquid state laser, and commonly used example. So let's move on to the okay. What is a laser? Laser is light amplification by stimulated emission of radiation, and this laser light is monochromatic and also coherent. So in this working of a laser only, what happens is you give a you have an electrical input which is here, and you give that electric input to a xenon gas tube which is surrounding a laser crystal. So this can be a laser crystal, like what I said, a ruby crystal, Nd:YAG, or CO2. Or it depends on what laser material you're using. So the basic principle behind all this is same, and so you have a helical tube which is actually surrounding that. So when this electrical energy is given to this xenon tube, what happens is this electrical energy is converted to an intense white light by the xenon flash tube, and that you can think it as how it happens. It actually takes in energy, then it goes to an excited state, and then when it comes back, it releases actually that photon. So since it is maybe releasing in lot of wavelengths, all of them combine to a white light, and that intense white light is now be is strikes on the laser crystal. And what happens there is, in the laser crystal, this atoms in the laser crystal, each atom has energy levels, right? So the electrons in one atom goes to a higher energy level, okay, because of this high intense white light from this xenon flash tube. And and that when those electrons come back to the ground state, they emit photons. And 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 many of these atoms will, the same procedure will happen. They get excited, then they come back and they emit photon. And and when and you should also understand that many of them will already be in a high state, okay, they may not be coming down. So so, so when these photons, there are mirrors here on both sides, okay, this is actually called a completely 100% reflective mirror, this is a partial reflective mirror. So these mirrors will reflect these photons, and these photons, I have said that some of these electrons are already in the higher energy, and they will stimulate those photons to come back to the lower energy. So what happens? So one, indirectly, energy conservation is all working over here. Thing is, the electron is already in the higher state, so for it to come back, there should be some stimulation. This photon is stimulating the electron to come towards ground state, and hence one photon is now causing two photons to get come. So each photon, so that is what is called light amplification by stimulated emission of radiation. So your light is amplified by stimulated emission, like one photon is stimulating other photon. So that is how it works. So, and there are a lot of videos on these things, you can actually learn about the laser. So what happens there, and that laser light is now coming out through a parallel rays of this through a hole here, and that is focused onto our workpiece. And due to this kinetic energy of these uh, photons is converted to heat energy here, and you actually melt that point is now melted, and you can weld that area. So you're melting, then it is cooling, right? So it is welding is happening, right? So what happens is the laser beam is now focused to a small pot producing a power density of, this is a very high power density at a single pot, due to, and hence you are able to convert the kinetic energy of a photon to heat and thus use it for welding. So this is the principle behind laser welding. So now we can move to TIG welding. So what TIG welding is tungsten inert gas welding. So tungsten here tungsten is the electrode we are using. That is why it is called that is why it is called TIG electron. So here what happens is, so you have a welding power source over here, okay? So this power source can either be an AC or a DC power source. So for welding aluminum and all, we use an AC power source. The reason they are giving that is because of AC, there is less oxidation on the surface. It's what they are saying. That's what actually happens. So I didn't actually understand the correct internal meaning. So if anybody knows how this is preventing, so one reason I feel is because the tungsten electrode also has, so when you're switching AC, the tungsten electrode also is getting heated up in that case. So there is a less heat which is on here, less heat compared to what was there before. But still, I don't understand how that will have a huge impact on reducing oxidation. So that is what I read. So if anybody has a good explanation of how AC is helping reducing oxidation on like in aluminum, or that is why specifically for TIG welding they use AC, so they can comment on that. So yeah, let's move on. So the idea is, so if I use a DC supply here, what happens is the tungsten electrode will be given a negative potential and workpiece will be given a positive potential, okay? So and when I, so there is a gas supply also. So what this gas supply is doing is it acts as, it provides us a gas here. It can be argon or helium, etc. It need to be in any case. So what happens is it prevents oxidation in this region. Okay. So that is what the use of gas supply is. And and then so now what happens is, so now in your, when you are actually bringing this electrode nearer and nearer, what happens is the electric field starts increasing, okay? And at a point what happens is the an electric arc will be produced in this region. This electric arc will excite the gas molecules in this region, okay? And that will produce a plasma in this region, okay? So how is plasma produced? So you have some electric energy that is exciting the gas molecules in this region, and they are ionized actually. So and that is actually so when these ionize actually again take in the electron, they will release a form of energy, and then they are like that, they are, the gas molecules coming back to the ground state and they release energy. So the plasma, you can actually see how what is plasma and things. So ultimately what I mean to say is that this plasma is what is producing the heat in this region. So many people have a misconception here, like this is like ice, like the power is due to the I square R. So and the heating is due to Joule's heating. Yeah, I'm just saying that because some people had a misconception in that region. So it's not that, it is the plasma in this region which is producing the heat energy, and that heat energy is melting the workpiece, and hence you're able to weld. So so one use of this tungsten has high melting point. And it is a non-consumable electrode also. What does non-consumable electrode mean? Non-consumable electrode means this electrode, tungsten electrode, is not being consumed in this welding process. So some welding process actually uses the electrode itself as a filler material to weld. Okay, so in this case, this tungsten electrode won't melt. It is a non-consumable electrode. So TIG welding is especially used in welding thin materials of 8 to 10 millimeter, and where you need high quality welding is required. Okay, so if you want to weld much thicker pieces, then you can use a filler metal to weld. Okay, so that's it. So that's about TIG welding. So now we can compare about laser welding and TIG welding. So in laser welding, you have a focused beam of light is used to create a heat. So that is what. So you have a kinetic energy of this photon is converted to the heat in that region. So in electric arc, in TIG welding, electric arc produces a plasma which produces the heat in that region, and where it is used for welding. So and one thing you know in laser welding, there's a lower heat input into the surrounding material. You don't want the out, you want only maximum heat to be at the point of where you're welding, right? The outside area should have less heat. So in laser welding, it is there. So, and because of that, you can see that there is less or no bending of the material in laser welding, but there is a bending of material in TIG welding. Okay, so and the aspect ratio of laser welding is much higher compared to TIG welding. For micro welding, it can even achieve up to 1 to 1.5. Aspect ratio is depth to width ratio. Okay, and in laser welding, you can achieve more cleaner joints, less contamination compared to TIG welding. So when you look at all this, when you can see that laser welding is much better compared to TIG welding. So
So if laser welding is so much good compared to TIG welding, then why shouldn't it replace TIG welding? The main difference is that the laser welding has very high cost compared to TIG welding. Like can at least it will be laser welding at least 10 times more costly or even more than that compared to a TIG welding. So that's all this video. Thank you.